Hello, this is a video on how to name ionic compounds, specifically binary ionic compounds. Before we get started, I want to briefly remind you about the difference between an ionic compound and a molecular compound. In molecular compound, the prefix in the name indicates the subscript. This is not the case in ionic compounds. For ionic compounds, the main understanding needs to be that the actual chemistry in an ionic compound comes from the atoms losing and gaining electrons to form their ions. And then they hang out together because of Coulombic force, electrostatic force. Now, how do you know how many ions do you need for each, the cation and anion? The rule is that every electron that's lost by the cation has to be gained by the anion. So the way we say it is that the total positive charge has to equal the total negative charge. And what that means is that the subscript is the number of cations that you need to put together so that the total positive ions, meaning the total number of electrons that's lost by the cations, is gained by the anions. So the subscript for the anion is the number of anions you need so that when you add up all its total negative charge, it equals the positive charge, total positive charge. So, and that's how you determine subscripts in ionic compounds. They are simply the number of ions you need so that the total positive charge is equal to the total negative charge. So this type is called binary ionic compound, which means that the cation and the anion come from just elements. Now, the other big overarching thing you need to remember about ionic compounds is the cation always goes first, the anion always goes second. That's the rules. So just like in any of these naming compound figures or papers, I did the chemical name to chemical formula first, and then I do the chemical formula to the chemical name second. So by now you should have opened up your naming binary ionic compound handout. So if you look at the example, and I'm simply going to go through the example. The chemical name is calcium bromide, and it's a regular rules naming compounds. The first word is the first letter of the first word is always capitalized. The first letter of the second word is never capitalized. So to find the chemical formula, the first thing you want to do is you need to know what the ions are. So the first word is always the cation. So calcium ion is, as you can see, Ca. It's actually supposed to be 2 plus, not plus 2. So I will change that later. Then you write down the anion name, which is bromide, which is Br again 1 minus, not minus 1. Okay, it's a little technical, but we'll get to it later. So now what you do is you see that the calcium lost 2 electrons, the bromine gained 1 electron. So that since the total number of electrons lost by the cation must equal the anion, equal the amount of electrons gained by the anion. So the first guess is always 1 cation, 1 anion. Well, that can't work because calcium loses 2 and bromine only needs 1. So the next guess is, of course, using logic, that you would want 1 calcium and 2 bromines. Okay, and when you do that, you see that the calcium ion loses 2, and each of the bromine only wants 1. So both of the calcium ion, both of the electrons lost by the calcium is now gained by the two bromine ions. So, but you need two of them because they're each going to take one. So then when you actually write the chemical formula, you don't put charges in. So what you then show is the subscripts, and now this is the important part, the subscripts is the number of ions you need so that the total positive charge equals the total negative charge. And as you can see that on the positive side, the total positive charge you need is +2. So you only need one calcium ion, so that's why it's Ca1. And then on the bromine side, the anion side, since the total positive charge equals the total negative charge, on the anion side, the total positive charge is -2. But each bromide only wants one, so therefore you need two of them, and that's why the subscript is Br2. So that's how you find the chemical formula for an ionic compound. What I would expect to see for work for this one is after I gave you the problem of calcium bromide, you would show me Ca2 plus Br1 minus, and then leave a little space. Then you show me the chemical formula, which is Ca1 Br2. So step 2, you don't have to show me. Okay? And you do that for every single chemical name to chemical formula. In reverse, or opposite, what you're going to then do is you're going to have, you can also have a chemical formula, and you got to give me the chemical name. So the example here is Na2O1. So Na 1 plus has the name sodium, and then the O1 is the indication it's only O. Because O is -2, and again the subscripts are the way they are because of what we had talked about in the previous example. So all you do is name the anion. So the anion name, of course, is drop the ending and add IDE, because you've been memorizing them all the anions all along. So therefore, that oxygen, you drop the ending and add IDE, and it's called oxide. So the name is sodium oxide. Remembering that the first word is the cation name and second word is the anion name. Prefixes don't apply here. And of course, the first letter of the first word is always capitalized, and the second word, first letter of the second word is never capitalized. Okay? And for these, there is really no work to show. You simply just give me the name. Okay? So that's how you name binary ionic compounds, either from chemical name to chemical formula or chemical formula to chemical name. So just in recapping, the most important thing is the subscripts mean the total number of ions you need so that the total positive charge, i.e. how many electrons have been lost by the atoms that are now the cation, must be equal to the total negative charge, which is the number of electrons that the anions have taken in. And the subscripts are the number of each of the ions you need to make that happen. Okay, and for now, if it's a 1, you must still show the 1 as a subscript. So every single thing has a subscript. Okay, I hope this helps. And there are 2 more of these, one with polyatomic ions and one with cations with more than 1 charge. So you will need to see those videos also. Have a good day.